This is an example of an A-stream problem like the one that I did in class. If a perpendicular line to AB passes through the midpoint of AB and segments are drawn from any other point on the line to A and B, then two congruent triangles are formed. First, you have to draw the drawing. It's going to look much like what we did in class as the construction. It doesn't have to be perfect. You just want to show that you have A and B and that you have a midpoint and that this is the perpendicular bisector. So it's perpendicular and passing through the midpoint. Then you need to write out what's given. The given is basically what's after the if a line perpendicular to the midpoint and the segments are drawn. So the given would be from the drawing that this CM is perpendicular to AB and M is a midpoint. Then what we want to prove is that triangle AMC is congruent to triangle BMC. So of course we need to have our two column statement column and reasons column. I'm just going to move this up a little bit. So we have, for the statements, the first statement should be the given. Now, you don't have to write every single given. I'm going to go ahead and use this as the first given, and then I'm going to make a conclusion based off of this given. So here we have that this is a right angle, and we know that angle AMC will be congruent to angle BMC because if two lines are perpendicular, then they form congruent adjacent angles. So notice here that I'm using the symbol for perpendicular, I'm using the symbol for congruent, and I'm using the abbreviation for adjacent. Next step, M is the midpoint. That is also given. And a conclusion that we can base off of M being the midpoint is that AM is congruent to MB. And that is definition of midpoint. Now it's definition of midpoint because we're basically told that a definition of midpoint is the point that divides a segment into two equal parts. And so if we have a midpoint, then we have two congruent parts. So let's recap what we have. We have congruent angles. We have two congruent sides. So finally, this looks like we're getting to a side angle side situation here. So we're going to go ahead and prove CM is congruent to itself, and that's by the reflexive property. Finally, the last step. So we have two corresponding pairs of sides congruent with an included angles, corresponding angles that are congruent. And so these two triangles, AMC and BMC, are congruent by the side angle side postulate. Now in class I demonstrated how to get the side, which that is also correct. I just wanted to show you guys a full, complete proof based off of given a condition, not just what you are given and prove. This would not be the problem. This is the only problem.